Students, in the last video, we started understanding factors affecting the rate of a chemical reaction. So, I told you that factors affecting, there are 5 factors which are going to affect the rate of chemical reaction. Now, which are those factors? Nature of the reactants, size of the particles of reactants, concentration of the reactants, temperature of the reaction, and catalyst. Now, in those 5, we understood nature of the reactants and size of the particles of reactants, how these two are going to affect the reaction. That is how it is going to affect the rate of a chemical reaction. Now, let us study and understand the third one, that is concentration of the reactants. So this factor, that is concentration of the reactant, how it is going to affect the reaction, that is the speed of the reaction, rate of the reaction. Let us consider the reaction of dilute and concentrated hydrochloric acid with calcium carbonate powder. Okay, so to understand this, what we are going to do is we are going to consider the reaction of dilute and concentrated hydrochloric acid with calcium carbonate powder. Okay, so you're going to take calcium carbonate powder, and then we will see how it is going to react with dilute hydrochloric acid and then with concentrated hydrochloric acid. So first we'll see first with dilute hydrochloric acid and then concentrated hydrochloric acid. So this calcium carbonate, how it's going to react with this two, let us see. Now see, dilute hydrochloric acid reacts slowly with calcium carbonate and thereby calcium carbonate disappears slowly, and calcium carbon dioxide also liberates slowly. On the other hand, the reaction with concentrated hydrochloric acid takes place rapidly, and calcium, that is calcium carbonate, okay, disappears fast. Now see, you have taken calcium carbonate in 2 test tubes, and then in one of the test tube you are going to add dilute hydrochloric acid, and in the other test tube you are going to add concentrated sulfuric acid. So then you will observe how fast the calcium carbonate in both of the test tubes is going to disappear and carbon dioxide is liberated. Now, and when you add dilute hydrochloric acid, the reaction is going to be very slow. That is, carbon dioxide, liberation of carbon dioxide is also going to be slow, and the disappearance of calcium carbonate is also going to be slow. Whereas with concentrated hydrochloric acid, the calcium, that is calcium carbonate, is going to disappear fast. Okay, yes, and see, I'll show you. On the other hand, when it is reacting with concentrated hydrochloric acid, what's going to happen? Calcium carbonate is going to disappear fast, as well as carbon dioxide is also going to is going to be liberated very fast, very rapidly. Now, concentrated acid reacts faster than dilute acid. So see, you're going to compare this two, isn't it? That is concentrated acid and dilute acid. So what is going to happen? Concentrated acid is going to react faster, whereas dilute acid, it's going to react slow, which means that rate of reaction is proportional to the concentration of reactants. So this is telling you that the rate of reaction, okay, yes, the rate of reaction is going to be directly proportional, okay, yes, to the concentration of the reactants. See, so the rate of the reaction is going to be directly proportional to the concentration of the reactant. Means what? the rate of reaction is going to be fast if if concentration is more. If the rate of reaction is going to be slow if the concentration of the reactant is less. So it is directly proportional. Now, the fourth factor that is going to affect the rate of reaction is temperature of the reaction. While studying decomposition reaction, you have carried out decomposition of limestone. In this activity, the lime water does not turn milky before heating the limestone because of the zero rate of reaction. From this, it is learned that the rate of reaction increases on increasing the temperature. Now, this activity also I had shown you. What you had done, you had taken some limestone powder, isn't it, in a beaker, and that is in a conical flask, and then in another conical flask you had taken lime water, and then what you had done, that is the limestone which you had taken, okay, to that conical flask you had fitted a cork with one hole, okay, then you had attached a this one bent tube, and then the other end of the tube you had dipped it uh, in the lime water, isn't it? And then when you heated this limestone, yes, what happened? The lime water turned milky, isn't it? But see, if you don't heat the limestone, then what is going to happen? The lime water is not going to turn milky. Now, from this, what you that is what you are going to come to the conclusion. Which conclusion you are going to come to? Now, see, if that is in this activity, the lime water does not turn milky before heating the limestone. Correct? Now, it's going to turn milky only when you are going to heat the limestone. Why is this? See, because of the zero rate of reaction. So, from this, what you are going to learn, that the rate of reaction increases on increasing the temperature, isn't it? So, what you that is what you are which conclusion you are going to come to, what you are going to come for. See, that the rate of reaction increases when you increase the temperature, isn't it? So, see, rate of reaction is going to increase, yes, when you are going to increase the temperature. Now, the next factor which is going to affect the rate of reaction is catalyst. So, on heating, I've told you what is a catalyst. The substance in whose presence the rate of chemical reaction changes without causing any chemical change to it is called a catalyst, isn't it? The substance called as, okay, the substance which is in its presence, what is going to happen? The rate of chemical reaction is going to change, okay, it's going to speeden up. The rate of reaction is going to take place fast without causing any chemical change. It itself is not going to take part in the reaction. That means what? The catalyst is not going to take part in the reaction. But what is going to happen? In presence of the catalyst, okay, the reaction is going to take place faster. So, see, on heating potassium chromate, okay, see, on heating potassium chromate decomposes slowly. What happens? See, on heating, when you heat, okay, potassium chromate, okay, it is going to decompose slowly. So, see, potassium chlorate, the formula is KClO3. So, when you heat, what happens? It forms potassium chloride, and oxygen is liberated. The rate of the above reaction neither increases by reducing the particle size nor by increasing the reaction temperature. However, potassium chlorate decomposes rapidly in presence of manganese dioxide to liberate oxygen gas. Now see, this potassium chlorate which is there, okay, this potassium, one reactant is here and it is giving us two products, okay. So which reaction is this? This is decomposition reaction, right? Yes. Now see, in this decomposition reaction, potassium chlorate which is there, yes, what is going to happen? It is going to decompose into potassium chloride and oxygen. So you're going to supply heat to this. So you have supplied heat, right? Yes. Now, even though if you supply heat, okay, the reaction still it is going to take place slowly only. The reaction is not going to take place fast, okay. Now, instead, what you can do, if in the presence you think you are adding manganese dioxide, okay, to this. Now, when in presence of this manganese dioxide, potassium chlorate, okay, immediately decompose to liberate oxygen gas, okay, and form potassium chloride. Now here this manganese, just in the presence of this manganese oxide, okay, the reaction is going to take place fast. So no chemical change takes place in manganese dioxide. So this manganese dioxide which is there, no chemical change is going to take place in this reaction. Though you have added manganese dioxide, it's going to remain just like that. But what has happened? The reaction, the decomposition reaction of this potassium chlorate has taken fast. The decomposition reaction of potassium chlorate, this reaction has taken place fast, okay. It has speeded up the reaction. The substance in whose presence the rate of a chemical reaction changes without causing any chemical change to it is called a catalyst. The decomposition of hydrogen peroxide into water and oxygen takes place slowly at room temperature. However, the same reaction occurs at a faster rate on adding manganese dioxide powder in it. Now see, this manganese dioxide again, okay, one more example where it is acting as a catalyst. See, the decomposition of hydrogen peroxide, that is H2O2. So this is hydrogen peroxide. Now see, it decomposes into water and oxygen. Yes. So see, you can balance this equation. See, H2, 2 hydrogen atoms here, left side, 2 hydrogen atoms right side, okay. So hydrogen has been balanced, but oxygen, you can see 2 oxygen and here 3 oxygens are there, right? Yes. So you can do one thing, if you add, okay, so 2 oxygen here, 3 oxygen here, right? So you cannot make 3 here. Instead of that, if you do this 2, what will happen? Now there are 4 oxygen atoms to the left hand side, right? Right hand side, how many? 2 plus 1, 3, right? But hydrogen also has increased. 2 2s are 4 here, right? So if you do this 2, see, 2 2s are 4, okay? 4 hydrogen atoms, 2 oxygen plus 2 oxygen, 4. This side also 2 2s are 4. So 4 oxygen atoms. Now it is balanced, right? Yes. Okay. Now see. Okay. Now it is balanced. Now what I wanted to tell you is this hydrogen peroxide, it is going to decompose into water plus oxygen, okay. Now this decomposition which is there, okay, it is going to take place very slowly at room temperature. So this reaction, okay, which is there, which is going on, the decomposition reaction, it is going to be very slow at room temperature. However, the same reaction will occur at a faster rate Okay, the same reaction will occur at a faster rate when you add manganese dioxide to this. Okay, so this manganese dioxide which is there, okay, yes, it is going to behave as a catalyst, and due to the presence of this, yes, see, due to the presence of this manganese dioxide, the reaction is going to become very fast. Okay, so the manganese dioxide is behaving like a catalyst over here. Now see, now do you know one or more chemical reactions take place during every chemical change. So during chemical change, okay, one or more chemical reactions take place. Okay, some chemical reactions occur at fast speed, whereas some occur at low speed. So some reactions they occur at that is very fast, and some very slow. Now strong acid and strong base, okay, yes, strong acid and strong base react instantaneously. So you have seen the concentration of the reactant is going to speeden up the reaction. Now in our body, enzymes increase the rate of physiological reactions. So there are many enzymes which are liberated, okay, in our intestinal intestine, right? Yes, during digestion of food. Now this enzymes not only during digestion, but there are many hormones and enzymes which are going to increase the rate of physiological reactions. Perishable foodstuff gets preserved longer in a refrigerator. So the rate of decomposition of foodstuff get lower due to low temperature. Now see, this perishable foodstuffs, okay, they get preserved longer. Now here what is going to happen? The temperature is going to affect the rate of reaction, isn't it? Now the food which is going to perish soon, okay, when you keep it in the refrigerator, the temperature is very low over there, isn't it? So what is going to happen? The freshness is maintained for a longer time. So the temperature over here is going to affect the rate of reaction. Here the catalyst, the enzymes are behaving like a catalyst, right? Yes, now strong acid and strong base, here concentration. Now see, vegetables cook quickly on oil rather than on water. So here see, the vegetables which are there, they are going to that is cook quickly. When you cook it in oil, it is going to cook fast, but when you cook it in water, it's going to be slow. The chemical reactions are profitable in the chemical factories if the rate is fast. See, the chemical reactions when in industries, factories and all, okay, chemical factories, if the rate, if the that is if the reaction is fast, only then it is going to be profitable to them. Otherwise, it's going to be loss if the time taken is more. The rate of chemical reaction is important from environmental point of view as well. So the rate of reaction is going to be very important from the point of environment also. The ozone layer in the Earth's atmosphere protects the life on Earth from the UV radiation of the sun. Okay, so the ozone layer, you have heard about this, isn't it? That it is going to protect the life on Earth from which one? From UV radiations. So you know this ozone layer filters the UV radiations. So the process of depletion or maintenance of this layer depends upon the rate of production or destruction of ozone molecules. So this process which is there of depletion or maintenance of this layer, okay, it is going to depend on what? Upon the rate of production or destruction. If the ozone layer, ozone molecules gets destroyed fast, okay, and it's going to depend on the production as well. So the process of depletion, whether it is going to get depleted or whether it is going to get maintained, it is going to depend on the production or destruction of ozone molecules. Now see, because of the lockdown, okay, for 1 or 2 months, what happened? All the factories, industries, then the sun, even the vehicles, the pollution due to vehicles was very less, right? Yes, and because of that, what happened? You came to know that ozone layer, okay, the ozone molecules formed, and the hole which had been formed in the ozone layer, yes, it was recovered, isn't it? Yes. So this were the that is the 5 factors which were affecting, that is which affects the rate of chemical reaction.
Factors
Now see,
affecting
I'll
rate
show you a small clip, okay, to make you understand more. So for your further understanding, let just see the small clip.
reaction. The speed of a chemical reaction can be altered by changing some factors. The factors affecting the rate of a chemical reaction are as follows. Nature of reactants. Potassium reacts more vigorously than sodium when put in water. This is because the electropositivity of potassium is higher than that of sodium. Take a trough containing water. Put a piece of sodium, light yellow colored solid, in a trough of water. It reacts vigorously, wandering in the water, and disappears after some time. For example, 1 minute. 2Na sodium plus 2H2O water gives 2NaOH sodium hydroxide plus H2 hydrogen. Take a trough containing water. Put a piece of potassium, light pink colored solid, in a trough of water. Potassium reacts more vigorously than sodium and disappears after some time. For example, half a minute.
So see, sodium took more time than potassium. Okay, the rate of reaction in case of potassium was faster in this case.
2K potassium plus 2H2O water gives 2KOH potassium hydroxide plus H2 hydrogen. Effect of concentration of reactants. Concentrated hydrochloric acid reacts more vigorously with marble chips to produce carbon dioxide gas than with dilute hydrochloric acid. This can be explained by the collision theory. CaCO3 calcium carbonate plus 2HCl hydrochloric acid gives CaCl2 calcium chloride plus H2O water plus CO2 carbon dioxide. Concentrated hydrochloric acid is.
See, in this case you can see, okay, wait, see, concentrated hydrochloric acid, you can see the rate of reaction, okay, yes, see the rate of you can see here the rate of reaction is going to be fast in this case, okay, and the rate of reaction is going to be slow here because it's the dilute hydrochloric acid is taken in this.
Poured through thistle funnel into marble chips taken in the conical flask. Colorless gas of carbon dioxide evolved vigorously and collects in the gas jar. Dilute hydrochloric acid is poured through thistle funnel into marble chips taken in the conical flask. A little amount of carbon dioxide is formed and collects in the gas jar. In case 1, number of reactant molecules is high, higher concentration. Hence, number of collisions are also unlimited. But in case 2, number of reactant molecules are less, lesser concentration. Hence, number of collisions is also limited. This can be explained by collision theory. An increase in the concentration of reactants leads to an increase in the frequency of collisions, which increases the rate of reaction. Effect of pressure. When the pressure of the reacting system increased, the volume will decrease, resulting in an increase in the concentration of the reactants. When the concentration of reactants increases, the rate of reaction will also increase. Increase in pressure increases the speed of the reaction. If the total volume of reactants and products are same, then the pressure has no effect. Increase in pressure increases the speed of the reaction only if the volume of products is less than the total volume of the reactants. Take one volume of nitrogen molecules, N2, and 3 volumes of hydrogen molecules, H2, in a closed vessel. When high pressure is applied, piston moves downwards and molecules of nitrogen and hydrogen come very close. That is, concentration increases and collision also becomes effective, leading to the formation of ammonia, NH3, very easily. Effect of temperature. At low temperature, the molecules which possess sufficient energy to bring about chemical reactions by collision are very few in number. When the temperature is raised, the velocity of molecules will increase. And there will be many more molecules which possess energy greater than the threshold energy, resulting in the formation of activated complexes. So, at higher temperature, the reaction rate is faster than at a lower temperature. Effect of catalyst. A substance that alters the rate of a reaction without itself undergoing permanent change is called catalyst. In a chemical reaction, before reaching the equilibrium, activated complexes are formed. The molecules should have a certain minimum amount of energy to form the activated complex. Often this energy is so high that very few molecules can reach that level. When a catalyst is present, it offers another easier path for the formation of the activated complex. The catalyzed route requires only a lower threshold energy. In the manufacture of ammonia, iron is used as catalyst, and it enhances the rate of the reaction. N2 plus 3H2 in the presence of iron as catalyst gives 2NH3.
See, so you saw how the catalyst is going to affect the rate of reaction in this case, isn't it?
Reaction. Chemical reactions in general proceeds at different rates. The difference in rates of reaction is caused by several factors such as concentration of reactant, temperature, particle size, and presence of catalyst. Let's start with concentration. If the concentration of a dissolved reactant is increased, the reactant particles become more crowded. Therefore, there is a greater chance of the particles colliding. Thus, the rate of reaction increases. We can now conclude that the relationship between concentration of reactant and rate of reaction is directly proportional, since the higher the concentration, the faster the rate of reaction, and the lower the concentration, the slower the rate of reaction. Next is temperature. Once a substance is heated, the particles move more quickly and they have more kinetic energy. The particles collide more often and more of the collisions are successful. The rate of reaction, therefore,
See, I'll be showing you a small animated film as well so that I'm sure you will enjoy this. Yes, just see this for your more understanding.
affecting rate of reaction. Wait, what is rate of reaction? Rate of reaction is the rate at which chemical reaction proceeds. In simpler terms, the rate of reaction is how fast or how slow a chemical reaction occurs. But how does a chemical reaction occur? Reactions occur when two or more molecules collide with each other and must possess enough activation energy, which is the minimum amount of energy needed to start a reaction. Chemical reactions in general proceeds at different rates. The difference in rates of reaction is caused by several factors such as concentration of reactant, temperature, particle size, and presence of catalyst. Let's start.
See, I have explained this to you. I have shown you one more, that is the clip before also. But this is an animated film, so I'm showing it to you again.
With concentration. If the concentration of a dissolved reactant is increased, the reactant particles become more crowded. Therefore, there is a greater chance of the particles colliding. Thus, the rate of reaction increases. We can now conclude that the relationship between concentration of reactant and rate of reaction is directly proportional, since the higher the concentration, the faster the rate of reaction, and the lower the concentration, the slower the rate of reaction. Next is temperature. Once a substance is heated, the particles move more quickly and they have more kinetic energy. The particles collide more often and more of the collisions are successful. The rate of reaction, therefore, increases. Same with concentration, temperature is also directly proportional to the rate of reaction. As temperature increases, the rate of reaction also increases and vice versa. Particle size. Smaller reactant particles provide a greater surface area which increases the chance for particle collisions, so the reaction rates increases. Therefore, larger particles have small surface area while small particles have greater surface area. If the surface area of a reactant is increased by cutting the substance into small pieces by grinding it into a powder, more particles are exposed to the other reactant, increasing the rate of reaction. Presence of catalyst. Catalysts, for example, enzymes, lower the activation energy of a chemical reaction and increases the rate of reaction without being consumed in the process. Catalyst works by increasing the frequency of collisions between reactants, altering the orientation of reactants so that more collisions are effective, reducing intermolecular bonding within reactant molecules, or donating electron density to the reactants. Therefore, we can say that the lower the activation energy, the faster the rate of reaction, and the higher the activation energy, the slower the rate of reaction.
So students, I'm sure you must have enjoyed this today's part of video. Yes, and understood what I wanted to tell you also, the concept regarding this, the nature, that is how which are the factors which are going to affect the rate of the reaction. So please study once again, go through the textbook and go through the video clip also once again. So I'm sure you will be able to understand more clearly. Okay. Now in the next video, let us continue with oxidation and reduction.